Over the past 3-4 months, I've been working on my tube bender, and that's to make the roll cage. And the main reason for that is I could either have sent the Golf in and had a roll cage fitted to it, but the problem is I don't know exactly which way I'm going to be going with the car, and to make those decisions now would have been quite difficult. The only reason why I want to fit the roll cage now is just to give the body some stiffness, so that when I start fitting the engine and the drivetrain, I don't get any twist in the body. I think it's highly unlikely, but rather safe than sorry. So that led to making my own tube bender. So there were quite a few challenges along the way in making this tube bender. The primary reason why I've actually made one was because I already had this power unit available. It just needed to be cleaned up. I needed some new hoses as the hoses were perished. And it's a 3-phase unit, so I had to get a VFD in order to run it. So I run the machine quite low. The reason for that is because it gives you time to bend slowly, and if you make a mistake, if I overbend, it just stalls the motor. I'll show you here. If I go all the way out and the cylinder bottoms out, it just stalls the motor. So I can't really damage it. But at high RPM it might do some damage. The dial gauge is just a 3D printed gauge, and it's got magnets all the way around which holds it on. And it just goes from 0 to 180, which you just put on the end, and then you rotate it according to this little piece of wire here to zero it. And then as the machine bends, that just goes up through the reading according to how much you want to bend to. So very simple. The one thing that I do need to change is this clamping mechanism. The way it works now at the moment isn't very good. It actually needs a bolt that goes through that pushes this and clamps this together. Going sideways here isn't really effective. It works okay, but it'd be a lot easier if I had just a single bolt driving through and clamping onto the tube. So that is a thing that I'd probably change for the future. To change the die is really easy. You just need to pull out the locator pin and the actual main pin, and then the die comes out. And then to replace it, it's exactly the opposite. And then the locating pin. Just like that. It's all constructed from 16mm mild steel plate, which I had laser cut, and then I had to redo the die because the first one didn't work. That is a fail, but this die works really well. The cylinder that I'm using is a 350mm stroke and a 60mm bore, and that works really well. The power pack is a 1.1 kilowatt motor. So like most of my projects, once I get to a certain stage, like now for example this tube bender is working, to try and complete it and finish all the little things, you just find that you just don't get the time to doing it. Like take for example, I need to put little handles on the end of these. And because I'll hardly ever use this machine again, to spend that time on there, I could be doing something else more valuable with that time. So I don't think I'm actually going to be doing anything more to this tube bender at the moment. But just to show you the process of making it, the steps that I had to go through to get it working, yeah, let's have a look. The next step in the puzzle is cutting out this ISO board so that I can make a casting. Let me show you what I'm talking about. So I'm busy cutting a block of ISO board down so that it looks like this. And then from here, I'm going to glue the two together, and then we're going to cast this in aluminum. And that is, you can see the half moon there, that's where the tube runs. So this one's actually a reject because the hole that I made, you can see there cut beautifully, and then the bit got full of ISO board. It melted onto the bit, and you can see it gouged a massive hole in there. So either it's cut a new one or have some fun trying to fix that. We'll see how it goes.
It's not going to work.
You don't think so?
No, it's collapsed here. Wonder why.
It's the epoxy, it's a mess.
Okay, next.
I wonder.
Cut out a G10 on the CNC.
So this shrunk, that shrunk. And this also shrunk, eh?
Yeah, this collapsed. But you can see here it's split. You can see how it popped out here.
That was the initial pour, what?
I don't know. Check how thick this is here. This should only be this thick. Check how thick it is. I mean, I
But
can
it's
sit
thick all the way around.
Yeah, you can grind that off. So it actually lifted or something.
These weren't big enough. It couldn't breathe. You think?
I don't know. There's a lot of toxic fumes coming out of it.
Yeah, but it was coming out here, not these. I only saw these vent at the end of the burn.
That's when I saw it going from the beginning, the smoking, and then the straw wing.
But this also shrunk, huh?
Okay.
TN19T, which is really soft when it hasn't been tempered. But you'll see later on, we'll temper this. We'll stick it in the furnace, take it up to this cherry hot, and then temper it. And then it becomes as hard as nails. And I'll show you on a little test how much harder it's going to be. But let's get them cut for now. We have an intruder. What's going on, George? Careful, man. Crazy dogs. Okay. So I've got this really old power unit. Can't remember even where I even got the thing from. I think it was Facebook Marketplace, but I've had it for probably about 4 or 5 years. And today I'm going to clean it, give it a bit of paint, give it a bit of love. So it's almost 9 o'clock at night, and I just got to show you this. You can see it's pitch black outside. But today my new laptop arrived for the scanner. And oh man, this thing is so impressive. I am so impressed.